basically what you've already done, just applying it to some real world problems on that second page. So this first page should all be reviewed for you, just kind of going over what the natural log is and common base log. You will have a test, chapter 13, on Thursday. Friday will be some SAT practice or a makeup day if for some reason you were not here Thursday. And then next week, we are just doing SAT prep. Okay, so make sure that you are logged on to Khan Academy. I know that we took a half a period for you to get signed up. If you could not get signed up, you need to do that on your own time, or when we're done this week, you can ask us how to get onto it. We just thought that was going to be beneficial for you because right when you come back from spring break, April 10th is SAT. So you'll come back on a Monday, which Ms. Truesdale will be back when we come back from spring break. Monday you'll come back. We're really just going to do more SAT prep, and then you take the SAT on Tuesday when you come back. Okay, so that's why we're giving you time in class to prep with us, especially if you can't afford to go to or want to go to a SAT prep class. Okay, and Ms. Truesdale actually tutors for SAT, so she's gotten some good material for us to work on. Okay, any questions about that? All right, awesome. So what is E? E is an irrational number. Irrational number with approximately the value of, does anyone remember what the approximate value is?
2.71.
Yeah, 2.71, something, probably rounds to 2.72. Okay, we've already talked about what E is last chapter, so this should not be new to you. It often occurs as a log function and in real world scenarios. Okay, that's why we use it in physics. If you are in physics and you have not seen it yet, it is coming. You'll be using E. E is like physics pi to us in math, where we use pi so much in math. E is like what it is for physics once you get there. Okay, so at least when you go to physics and you are using that E button, you'll know what it is. It's just like pi, 3.1415926. E is the same thing. It's just a number. A lot of you guys think it's a letter, but it's a number. It's an irrational number. So converting between forms. Convert each equation to exponential or log form, depending on what we have. So we're in exponential here. How would I convert it to log? Yeah, the heart thingy. How would I say it? Well, I hear in a couple of things. You have to start with logs. We don't have one yet. Base E of 24 equals X. Good. Okay, make sure when you guys say that in English terms, you're saying log base E. Because if you say log E, I'm thinking log E, which is not the case here. So log base E of 24, which is the argument. Okay, what about number 2?
Log base E of X equals 9.
Beautiful. Questions on that? All right. A lot of you see this ln. You're like, what is this ln? Or even people say in. It's the natural log. Natural log. Okay? So it's still a log. A lot of people don't recognize that. So make sure you do. Ln is still a log, and it has a base of E. Okay? And that's why it's called the natural log. And then in black, nothing has changed. So all I did was I rewrote it with the base of E. Now when I convert it using that heart method, okay, you're converting to exponential form. Make sure that you understand that and not just say, oh, use the heart method, because if another teacher, you go to another classroom, they might not know what you're talking about. You're converting it to exponential form. How would I do that? E to the, is equal to? Perfect. Questions, comments, concerns about that? That's all review. It should have been really easy for you. Now, a lot of people tend to, again, get stuck when you see these LNs, these natural logs, because you think it's not a log, but it is. Same thing. We've done this before. What would I have to do first in this situation we're solving? Yeah, simplify / condense. Okay, so on the left side of the equation, I have to condense. I have to condense the arguments. What would I do with the arguments? Careful. Divide. Whenever you see subtraction, you're going to divide. Remember, it looks like a division sign. So I have ln of 72 divided by 4 is equal to, what would I do on the right side? Yeah, I would distribute or I would multiply. I would do 6 times that whole thing. So I have ln of 6 times the whole entire argument. From this point, when you get the natural log equaling the natural log or a log equaling a log, what can you do? You can cancel them out. Take it from here, solve it. When you're done, and when you're done, only take a look up. While you are zooming by here, you should, because this is just review. Do you have questions? Did anyone not get 5 and want me to go over it? All right. Here, again, 2 different scenarios here we can do. We look at it and we say, okay, we need to have a log equaling a log, which we do, but we don't really yet, because this 2 out in front means something. You can, but you can't at the same time. Yeah, because if I divide by 2, it's still not leaving something isolated. Okay, you have to have just a log equaling a log for them to go away. Okay, this 2 is not really division. It's being raised to the exponent. So I have to bring it up. Now, you could divide by 2 if I just had 4. If I were to cross this piece off right now and I had 4 there, then I would say yes, divide by 2. It'll work. Okay, because when you divide by 2, it's not going to be 4 divided by 2. It's the natural log of 4 divided by 2. So it's a little different. So then I would have ln of m plus 4 all squared is equal to the natural log of 4. Now I can get rid of them. It has to be completely isolated first before we actually do that. We have to have just 1 log on each side. Now this is where a lot of people get stuck, because they'll just distribute the 2 into the m into the 4, but you actually have to do that first, outer, inner, last. So I'm going to rewrite it for you. M plus 4 times m plus 4. That's what it means to square. You square by itself is equal to 4. When we distribute, I get m times m, which is?
M squared.
And then m times 4.
16.
It's okay. We haven't gotten to the 16 yet.
Ah.
We're getting there. 4 times m is still 4m, and now 4 times 4 is 16. Go ahead and solve from here. You're going to have to factor. Take a minute and see if you can solve from here. You're going to have to factor. The goal is to get everything to the one side. I recommend getting it to the side that has the m squared on it. All right, take a look when you're done and done only. Okay, yes. Again, I can kind of keep over here in purple and say what multiplies to 12 and adds to 8. Well, that's 6 and 2. When I multiply them, I get 12. When I add them, I get 8. When you solve them, we have to cross off the negative 6. Why do we have to cross off the negative 6?
Because negative 6 plus 4 is negative 2.
Good. Really good. So if I plug in negative 6 right here, I'm going to get a negative argument, and that doesn't work. If I plug in negative 2, it still works, because 4 minus 2 is a positive 2, and that's okay. And that's why the negative 6 gets canceled out. Okay, so just practicing what you've already done. We've done this before. All right, now here. What do you think our first step would be here? Yeah, when in doubt, convert. So if you're like, I have no idea what to do right now, you hit the convert. Okay, so I have log base of is equal to, awesome. So a log base e is just ln. So ln of 57 equals x. And here's where you'd get out your handy dandy calculator and just type ln 57 and get your decimal. Okay, the natural log. You wouldn't be able to put log base e in there. I mean, you could, but it'd be log base e to the 1 power, which is just complicated. So knowing that this log base e, that's supposed to be a highlighter. This log base e converts into ln is super crucial for your calculator so you don't make any errors. What did you get? What decimal did you get? Yeah, 4.04, which is then equal to x, and we're done because there's nowhere else to go. Questions on that one? So this is just a really good review for you guys. Let's look at this next one. What do you guys think we should do first? Compress. Good. And you'll have to get one log on each side. Well, in this case, just on one of the sides. So what do I have to do with those two numbers? Not numbers, I should say one letter and one variable. Sorry, one letter and one number. So I have x divided by 9. The ln does not disappear. Look, a lot of people right now are like, okay, gone. Perfect. No, I have to convert. There's no log on the right side. That's huge. Most common error is that, just dropping the log. Well, ln is really log base e. So I'm going to rewrite that for the sake of notes. A lot of you might have just already realized that. Now when I convert, because when in doubt we convert, what do I got to do? E to the?
Power of 7 equals x over 9.
Very good. This is my little heart. So in your calculator, go ahead and put in e to the 7th power with your calculator. Good question. So because we're going from log to exponential, we're going to keep it with the e. We had to break it up. ln equals log of e. And then I convert. Okay? So this is no longer... Whenever you convert back and forth, make sure you know what you're going for. So I started with the log and I want an exponential. So if I'm starting with a log and I convert, I should no longer have logs. Okay? And vice versa, which is something that we did see on the quiz that we took. Make sure you understand that if you're going from log to exponential, which we are here, you should no longer have any logs. Okay? So what did you get when you had e to the 7th? It's a big number, I think.
1,096.
Oops. 0.63? 1096.63 is equal to x over 9. Then my last and final step. Very good. Yep. 9869.70. Good. Do you have any questions? All right. Now, here's what we were talking about earlier on this next problem. Okay, we have to isolate the exponent or the log, in this case an exponent. And if you don't have a highlighter, maybe box it off so that you know that that needs to be alone before you can convert. And now we can divide by 5 to both sides. You can't do that when there's logs sometimes because people will divide the argument, but that's not necessarily true. Okay, so I get e to the 4 to n power equals what number? 19. Very good. Go ahead and do this one because we just did this one like 17. So if you need something to look off of, go to number 17. But go ahead and solve this one on your own. See if you can do it now alone or with the group. Remember what e, log base e really is. So we're going from exponential to log, so I should have a log now. So always ask yourself, what am I going? Where am I converting to? And that might help you. When you're done and done only. If you're not getting these, please ask one of us. I round it to the nearest hundredth. We do that normally. If we don't ask, I would just recommend it. Do you have any questions on this problem? I'd be more than happy to go over any piece of it. Okay. So here, again, the goal is to get this exponent alone. If you highlight it. If you don't, then maybe box it to help you out, to help you see it. What would you do first? Yeah, I would subtract the 3, just like I would normally do if I was solving. So 2 to the 2e to the c minus 9 power is equal to 85. No. My gosh, I cannot add 84. Sevens are like my weakness. I don't know why, but sevens are like not a thing for me. What would I do next? It's still not isolated. This piece is still not alone. Divide by 2. In order to convert, it has to be alone first, otherwise it gets very messy. Which equals what? Very good. Okay, again, take it from here. So maybe it's multiple practice and repetition is going to help you and benefit you. It's just like 21 and 17. We just did one like it. When you're done, only go ahead and check it and flip when you're ready so I know that you got it. Okay, so when I convert, I got log base e of 42 equals c minus 9. But log base e I know is the natural log button on the calculator. So I can type that in and I get 3.74 and then I add the 9 over. Okay? Questions on that? Okay, now let's actually apply it to real life situations. Okay, this would be something that we might use it for. Same thing, we're going to be doing the same exact problems. The number of students exposed to the measles at school can be modeled by the equation, S equals 10 times e to the 0.15 t power, where S represents the number of students exposed after t days. Approximate how many days would it take for 34 students to be exposed. What part of the equation am I going to put in 34 students? S. Okay. So we go ahead and put 34 into S. 0.15 t power. And here we would just solve it like we have been. Solve it like we have been. This e to the 0.15 t power needs to be isolated, so what should I do first? Divide by 10, which gives me 3.4 equals e to the 0.15 t power. Okay, and go ahead and solve it from here because it's just like the ones we've been doing, 22, 21, 17. Okay, same exact type of problem here. Here's the first step if you're getting stuck. Remember, when in doubt, you convert. Which in this situation, you might be like, I have no idea what to do. Well, and when you get that feeling, it's probably because you have to convert. Okay, when you're done, and done only, take a look. Okay, approximately 8.16 days. That's how long it's going to take for 34 students to be exposed to the measles in this situation. Give you a second to make sure everything is correct. If you're still working, please try the problem. Don't just copy from me. Feel like the next one's pretty straightforward, so I'm just going to skip to the last one. Question?
Yeah, what'd you get 8.16 at?
So when you do 1.22 divided by 0.15, I would double check that. Am I right?
0.3. It's like 8.13.
8.13. Oh, okay. I mean, we would not like really hurt you on that because what I did is I like didn't chop that off. So yeah, if I do 1.22 divided by 0.15, 1.2. Oh my God, calculator. 0.15. Yeah, it is 8.13, but I didn't put that in my calculator. So yeah, I'll just put 8.13. That's fine. All right, cool beans. I feel like this next one is pretty straightforward. We've done a lot of these problems, so I'm going to go to the last one because I feel like it's a little bit harder, and then I'll give you guys the homework. The formula, as shown, models the velocity of a spacecraft as it relates to its mass ratio. My physics people, anyone? What will the mass ratio be when the velocity is 8.033 kilometers per second? Good thing I taught a little bit of physics this year. All right, so when I plug this in, what variable is it going into? The V right here. So 8.033 is equal to, everything else is going to be in black, so I'm not changing it. Just coming from the formula. It looks weird because most of the time when you're talking about real life scenarios, it's going to be a weird situation. Going to have some decimals in it, and that's okay. Now the goal is, in my highlighter here, or I'm going to box it, the ln of r needs to be alone before I can do anything right now. So what would I do first? Yeah, very good. I'm going to add the 0.98 to both sides. 0.98. And when you do that, do you get 9.013?
Yes.
Awesome. In black, nothing has changed. ln of r. This guy still needs to be isolated. Like I said, I know it's weird, but until you get used to it, maybe boxing off the log part will help you. What would I do next? Yeah, divide by 2.8. It cancels out. And I get, 3.22-ish. And in black, this part has not changed. Now, we're back to what we're used to on those previous problems. ln really means log base e, and I'm just making you say it a million times until it's stuck in your head. And go ahead and take it from here, and you get your homework if you get it right. Like, all you're doing is converting back and forth. We're doing that to you guys so that you guys keep remembering how to convert back and forth. If it helps you, on the top of your paper or in that yellow sheet that we gave you, when we have log base b of the argument equals x, remember it goes back and forth to b to the x power equals a. If that helps you until you get used to it, keep writing this out until you get used to it. Okay, at this point, hopefully you have, because we've been doing it since last chapter. But just in case you don't, write that up. Maybe even highlight each piece so that you know, like, that's where they're going. That's where they belong.
Where is our ln for log
So this one, there is, this one there is no e, but it's going to be your common log when you convert. So the common log would just be like that log button. Because it has a base of 10, right?
Yeah.
So that's what you're doing here.
Okay.
Yeah, so number one, you're not working with E or ln on the back with word problems. I know there's two number ones. But actually, no, it's the front. But that log, it's just going to be base 10, which we should know is the common log.
So we just did all 17.
I know the numbers are all funky because we cut some out.
That's what I was thinking.
Yeah, we just cut some out, pasted it.
No, I meant